Hey, good morning, everyone. Thanks for coming to my talk. I hope you're having a good last day at Devoxx today. Today, just a heads up, this is a sponsored talk. We're going to be talking about a little bit about CDNs in general, what they do, their role, how they can support developers. More importantly, how they should be automated and included in traditional CI/CD processes. But we will be getting into a few Akamai specific tools. I work for Akamai, but we're going to try to keep this as high level as possible so that can be applicable to other CDN technologies or vendors. So real quick, a little bit about myself. My name is Duncan McAllister. I'm a consultant working for Akamai in the Global Consulting Services. So what I do is basically help customers, optimize the performance of their websites. I do analysis on their various web properties and APIs. But more importantly, I act as a developer advocate for Akamai automation products and help customers engage in projects to automate their usage of Akamai. So real quick, let's just quickly cover what is a CDN, right? So if you have a web application, anything that's hosted on the internet, any type of content or API, you need to have typically some type of acceleration or security around that, right? And CDNs provide that. Traditionally, these are done in the following ways. So the biggest one is obviously caching, right? CDNs are large distributed global networks with hundreds of thousands often of nodes that sit between your end users and your application, and they can cache various content locally as close as they can to the user, right? In the case of Akamai, we try to be at least one network hop away from the end user, right? So that every interaction between the customer and your site is as short of a geographic distance as possible. So caching not only helps in accelerating web experiences, but also helps in things like scalability, right? Because the more you're offloading traffic to a CDN, the less origin infrastructure and less bandwidth you're paying for at your data center. Additionally, it helps with things like stability, right? If you suffer any type of outage or momentary disruption of service, objects which are cached in the CDN will persist there and will be able to at least support some type of web experience, while the origin site is offline. For things that are dynamic or transactional that cannot be cached, we make use of various network acceleration techniques to help with that. So a good example of this is using we do mapping of various points around the internet to understand various places where congestion exists between various data networks. And then we use that information to potentially route around outages, dynamically do things like tuning various TCP parameters to make sure that the transmission between our network and the origin is as fast as possible. Additionally, we do things like content targeting, right? So we can use various pieces of information about the client, things like the device, the geolocation, to serve variants of content based on those characteristics. So a good example of that would be serving videos that are only allowed in specific geo, right? Because there's various digital rights management around that. Or potentially serving images scaled specifically for a mobile device viewport. The last is obviously security. So sitting in front of the origin, we are able to inspect the requests of various from various clients and look for things that are malicious, right? We're looking for SQL injection threats. We're looking for things like credential abuse, and we're trying to stop that before it gets to your data center. Another thing is a big one is denial of service, right? So there's distributed attacks, and distributed attacks that against your origin require a very large distributed defense. And the way we do this is just with extreme huge number of computing nodes that can essentially absorb or hopefully are larger than whatever threat is trying to do harm to your business. So these are all traditional, I guess, use cases or features of a CDN. And pretty much every CDN out there offers these. But these are more focused on non-functional kind of things, right? These are the scalability, performance, security, right, aspects. And traditionally, these are all kind of concerns of the operations teams. But as kind of time progressed, we have all this compute power out distributed across the globe. The question kind of became, what else can we do with that, right? There has to be more use cases and kind of features that we should be able to be thinking about. And the goal is when you're thinking about, creating performant applications, creating fast web experiences for your customers, how do I leverage that compute capacity to deploy features as close as I can to the customer, right? So there's actually a lot of very interesting use cases that developers, like specifically front-end developers, may be interested in that CDNs can provide. So these range, I'm just going to talk about a few of them, but these range from things like application load balancing, so we can understand like the type of content that a customer is requesting and route based on various characteristics of that content, route based on their geolocation, route based on their device characteristics. We can even implement things like multivariate testing solutions, right? So we can do things like instrument algorithms within the edge network to assign the type of experience that a customer may want to view at the origin. Additionally, we can implement things like feature toggles, so we can have dark releases or canary releases and instrument those types of things using the edge network. And then, even more importantly, is we can actually dynamically assemble UI content at the edge, right? So we can take some of these information about the client and then actually dynamically construct some type of UI element based off those characteristics. So with all these things and all these capabilities, what we've seen is that there's like a wide array of actors that interface with the CDN. So there's also, in addition to like the development use cases, we have the obvious ones, right? Like the network engineers, they need to know, what are the IP addresses of the edge network so that they can configure firewalls and other security policies around that. We have QA engineers testing various features that are implemented within the edge and making sure they're working properly. Security people who need to curate various digital signatures of bots and malicious actors and define those using tools that we provide in the edge. And then maybe even sales and marketing people, right? So that like a good use case here would be a sales team that's creating like vanity URLs or specific sales sites that are activated at a specific time. So with all these various actors, traditionally CDNs have become like a choke point. It's a big monolithic network. It acts as a service. You have many people trying to introduce change. So it's very hard traditionally to introduce change into that quickly, right? So what do customers kind of keep asking for when it comes to solving this problem, right? Well, just like anything else, the velocity of the changes that we introduce need to keep pace with our origin applications and our internal applications. There could be various functional dependencies between what we have deployed in the CDN and the things that we're deploying at our origin, right? So the rate of change of those things needs to keep up with what we can do internally. CDN environments also need to be very easily obtainable for developers. Because there's so many various rich features that can be used through a CDN, we need to have some kind of mechanism for developers to play around with those features, right? It can't be just try in production or a limited number of environments to do that. We need to think about things like self-service to help familiarize developer with the CDN and those features, and make sure that that's reliable and performant. Additionally, we need feedback on what our changes are doing, like how those changes interact with our bottom line, how they motivate customers, how do they change the various KPIs that we care about, how do we know if things are breaking or even working in the CDN? These are all very important attributes. And then lastly, if things do break, we need kind of quick rollback mechanisms, right? We need the ability to quickly be able to reproduce issues by maybe like reverting to previous versions of our CDN configuration state in various environments, and also potentially deploy new features into production quickly. So how do we do this, right? Well, with everything, it's automation, right? So I guess the approach is we need to treat CDN configurations. We need to treat all this logic and behavior as versionable artifacts, right? They need to be included in some type of automated testing process, just like our everything else. They should adhere to the same kind of standards and scrutiny that our origin applications and our configuration do, right, internally. Just because it's a service doesn't mean we have to treat it any differently. And it also, the change to these artifacts should be commit driven, right? So as we make a change or introduce some type of new behavior, we want to make sure that just by virtue of doing that, automated processes happen to test and deploy those features. And then lastly, we need to eliminate as many manual steps as we can in the deployment process and provisioning processes. So these are like traditional just CI/CD tenets of any system, and CDNs need to adhere to those. So what are the things when we embark on a journey to automate our usage of these CDNs? What do we need to consider? The main ones are things like security, right? So we're deploying certificates to the CDN. We're provisioning new certificates, especially if we're doing things like creating, provisioning new environments. We also have to manage our various API credentials and tokens and secrets. Operationally, we use CDNs to do various like traffic shaping activities. If you have multi-data center kind of deployments, you might need to kind of hook into CDN APIs to manage that. Especially, this is very important for things like canary releases, where you're using maybe DNS-based solutions to shift percentages of traffic between data center A, B, and C. And then we also need to understand like cache management. So things like invalidation. If I have content that exists in the edge, I need some kind of mechanism to invalidate or remove that. And lastly, we need some way of provisioning environments, right? We need the ability to create, as we said, self-service kind of capabilities for developers to be able to provision. And we also need some kind of testing framework to understand how the behaviors are actually interacting. So what we've been doing at Akamai for the last year and a half, 2 years is we've really been trying to focus on supporting these various types of use cases. We've come up with a various number of tools, APIs, libraries that help assist in these types of endeavors. One of the big ones is we're really trying to work on an API-driven platform. Everything that we release, all new products, have some type of ability to be managed via APIs. And for everything else, we're actually kind of retrofitting API support around those products. If anyone's ever worked with Akamai, you know that we have a lot of different products. So that we obviously have a huge plethora of various API capabilities that we can provide to basically manage pretty much everything. In addition to that, our APIs are, they kind of adhere to a very strict authentication and identity kind of scheme, right? So in order to make that easier, we've provided a lot of pre-built signing libraries in various languages like Java, Ruby, Python, Perl, a lot. But essentially what this does is it really eases the process of authenticating with these APIs. So a lot of the work that I do is in Python. The way that what we've done is we've like extended the requests library for Python to be able to use this comprehensive authentication scheme. So it's really easy. All I have to do is just provision some credentials, provision a secret, and then just kind of pass that into my code, leverage that authentication class, and just start using APIs. Additionally, and this is going to be a main focus of the talk later, is our Property Manager API. So Property Manager is essentially a tool that we use to manage behaviors. We create conditions like, if content type is text HTML, then do something. So all CDNs essentially have some type of control interface. Ours is called Property Manager. And today we're going to be talking a little bit about the Property Manager API and how we can use that to instrument behaviors. The big thing that Property Manager API is really good for is actually curating and modifying these types of caching behaviors and other type of content assembly behaviors. But we also have a new product that we're working on is the CLI. So the CLI is really great because it really extends the ability to automate various CDN use cases outside of the developer spectrum, right? You don't have to be a developer or understand Python or do complicated request handling to interact with APIs. It's essentially a wrapper that we can use to interact with our various products that we're using. It supports the big ones, which is things like provisioning, cloning, activation, and also content invalidation and management of other various cloudlet policies that we provide. And one of the really cool aspects of the CLI is it has package management built in. So as the APIs underneath change, the CLI will automatically update and make advantage of those new kind of operations, right? So you don't have to, from a management perspective, I guess the benefit of using a CLI over our management APIs is that as the APIs evolve, you don't have to have any development overhead to actually take advantage of those new features. And we're going to be talking about the CLI shortly. So when we work with customers to automate CDNs, we've seen essentially kind of three approaches to doing this, right? And they kind of start with the very easy and end with the very complicated. The first one is essentially you're using CDN kind of tools and capabilities to manage your configuration. You're using the UI to introduce those behaviors, and you're basically using things like the CLI to deploy them. The next thing that you could do is actually, and what we've seen in a limited amount, is that customers will actually edit the raw configuration data and manage it internally, and then purely just interact with the CDN in a deployment perspective, right? So this is a lot more complicated because the markup that CDNs use, like Fastly and even Akamai, is pretty proprietary, right? So you really have to understand, the structure and the way of defining those behaviors. It also puts a huge emphasis on static code analysis, right? Because since you're not using the internal tools to make modifications to these artifacts, you could be introducing, really malformed behaviors or structures, right? It also reduces the portability across various CDN providers. So if you need to change CDNs, this could be very difficult. And lastly, what we've seen, which is actually kind of interesting, is maintain CDN behaviors via abstraction, right? This is essentially creating transpilers, right? Where we've seen some customers create their own markup language for the various caching and content assembly behaviors that they want to implement, and adapt those to basically compile a custom version of those configurations for the CDN provider that they wish, right? And now this is really, I guess, common for customers who like to do things like CDN load balancing. If they want to have multiple CDNs and be able to shift traffic between one or the other, they can use this mechanism to automate that. The problem with this approach, though, is you're kind of limited to the lowest common denominator of feature sets between each CDN, right? If Akamai supports some kind of really cool behavior like adaptive acceleration or server push, but CloudFront doesn't, then this transpiling method will only be able to leverage the common features between them. And that kind of restricts you as a developer in what you can do. So when we're talking about automating these things, what are the APIs out of all of them that we're really interested in? They really span, the configuration, security, and operations domains. So we need to think about provisioning. We need to think about cloning configurations from one to another, deploying configuration that we're managing to a specific environment. We also need some way to introduce our behaviors, which we talked about. Operationally, we're going to need to know how to invalidate content, how those APIs are structured. We're going to need to pull, have hooks into the logging and diagnostic tools that are available as well, so we can understand how those things are working in production. And then from a security perspective, we're going to need to know, as the CDN network changes, what are the IP CIDR blocks that we need to ACL on our backend, right? How do we construct our firewall policy so that we can safely interact with the CDN? And then additionally, we're going to need some way of provisioning things like certificates and API credentials. So all these things are typically what we would see in a common CI/CD pipeline for a customer who's trying to automate their usage of a CDN. So next, I wanted to kind of transition into some kind of real-world scenarios that we've seen in the wild here, right? So we've worked with a lot of customers who are doing this kind of stuff. Wanted to kind of show you how I guess the typical things that people do at a very high level when they're trying to highly automate these processes, right? And what do these pipelines really look like? So this is a very kind of high-level depiction of what we might see in a customer ecosystem, and I think the biggest thing to notice here is kind of the delineation of the internal pipeline infrastructure and the things that the pipeline relies on that exist outside of that, right? That are kind of vendor managed, and it creates this like tight integration between our internal tools and these services that we rely on. But the main components that we typically see are, we have some developers trying to introduce some type of behavior or feature. They're going to do that either via the UI directly, the CDN UI, or they're going to be doing that through some type of interface that DevOps engineers or release engineers are providing to the developer, right? Since there is a learning curve, it is common to see things like service catalogs exist where release engineers have given some kind of like conduit to developers to be able to provision these resources without having to know too much about how they work, right? Essentially like simplify that. There's also some type of task orchestration. We need to define a series of steps that's required to do things like provisioning, deploy, and activate, and we need to kind of codify that in some task orchestration engine. A big one we see is actually Jenkins using pipeline plugins, but we've also seen other implementations of other kind of like off-the-shelf BPM engines like JBPM or Activity. We also need to maintain our configuration, our metadata, and our configuration variables in some type of version control system. This is really key because pretty much all CDNs provide some type of built-in versioning scheme. So when you're using like a CDN managed property manager, they're going to be maintaining various states and time of those configuration artifacts. We're kind of trying to get past that and actually manage those things internally, right? And that's very important for a number of reasons, which we're going to talk about later. And then lastly, we need some type of testing framework, right? We need to build some type of mechanism to actually test these features, and this is very difficult because CDNs are essentially huge reverse proxies, right? Like, how do you test a proxy? So what does the sequence look like? And this is just mimicking and mirroring the traditional kind of like early stage development testing process. So once a developer introduces a feature, it needs to trigger our pipeline, right? And then we either, if the feature is introduced via manually, just by editing the raw markup, or using APIs, we need to perform some type of like static code analysis before we deploy that. Typically for Akamai, this comes in two forms, right? So we describe our configuration artifacts in JSON format, so we typically want to like lint that artifact to make sure it's structurally complete and sound. But additionally, we want to make sure that we're understanding various the structure of behaviors that are within this configuration. There are various technical dependencies between these behaviors. A good example of that would be I'm trying to instrument HTTP2 protocol support on my configuration, but I'm doing that on a configuration that doesn't have any kind of TLS configuration. These are dependencies that, if not met, it's going to break the configuration, right? So we need to rely on various validation services from the CDN, feeding our document or our configuration artifact to it to identify those and capture that information, right? Usually these will come in the form of warnings or errors, right? So next, we need to deploy that artifact and test it, right? We can do that by either deploying to a kind of long-living, pooled, non-production environment, or we can actually, what we've been trying to work with customers to do is actually provision ephemeral environments. So an environment which purely exists for a short duration, just to test a specific feature at a point in time. Then we need to do some very basic sanity checks. So we need to test is the CDN actually responding to host names? Have the various CNAME operations that I need to do in DNS to actually integrate my non-production environment with the CDN? Have that been done? Is it responsive to requests? And then after that, once we understand that the environment is in a functional state, we perform various integration tests, right? So we want to make sure on the back end that we're able to access our application, that our core business features are working in tandem with the features that we've implemented. From there, what we do is we take that feedback from both the static and integration testing, we package it up in our various commit messages and merge request messages. And from there, we use that event of reviewing the actual merge request to trigger some type of subsequent process, right? Like maybe additional testing or even deployment to production. So how do we test these features, right? So because CDNs are reverse proxies, they're kind of transparent. However, because of these advanced features, we can actually have entire request and response actually exist within the CDN and never actually even make it to origin. So how do we know what's going on? This is actually done using response headers, right? So most CDNs will actually inject various debug information if you request it into the response headers of your various HTTP requests. So this can be a little bit difficult with some of the off-the-shelf testing frameworks, right? Like Selenium doesn't really support HTTP header inspection. So usually you're going to have to write something custom to do this. But the things that you're looking to validate are things like what are the response codes that I'm getting back from my requests? What are the TTLs of the various objects that I've assigned in cache? And then what behaviors are actually toggled or enabled, and what are the state of those behaviors, right? In the bottom example here, we have kind of highlighted that the prefetching behavior is on. So we need to map for a specific object that exists within our UI application. Is that conforming to the behaviors that we expect it to, right? And we do that via these debug headers. Additional things you might want to look at are kind of just meta attributes of the request that are just kind of native to HTTP. Things like what is the protocol version, the content encoding, various other headers like cache control, vary, things like that, and content security policies. So when we're talking about versioning, right, we mentioned that the source of truth needs to kind of migrate from the CDN managed kind of version into some type of internal version control system. Things get a little weird here, right? Especially if we're relying on the services or console to make changes to our artifact, right? And the way we do that is with some type of staging environment, right? So typically what we've done is we have a dedicated, I guess, environment that it's not even really activated. It just exists purely for us to submit changes to our configuration, right? And when we use that as a basis to pull from to actually integrate into our CI process, right? From there, we want to make sure that we're capturing those changes on a short-lived feature branch and then doing all of our testing on that branch before integrating it back into some kind of mainline branch. And we do this for the same reason we do this for other development projects. We just want to make sure that if we break something, we're breaking it in this short-lived branch, and we're doing it without impacting master. And we know master is always safe. Additionally, we want to make sure that this cycle is as fast as possible because we don't want to have, we want to have all of our changes very micro and short and atomic, right? We don't want to have batched up changes. We want to commit frequently and often. So that means that our validation cycle needs to be extremely fast. So additionally, we want to externalize our configuration. And we do this via variables within the CDN. So this can get very difficult because the objective is we need to take a single artifact and have it be adaptable across multiple environment types. Where this can be really tricky is that your non-production and production environments can be very different from a topology perspective. You could have multi-origin, 2 data center production environments, but single data center QA or dev environments. So you need to structure your configuration and the origin environment to kind of work well together, right? And we do that via environment variables. The big ones to kind of consider are things like the origin, so what is the actual endpoint of where I should send specific requests, the status of various feature flags, and other kind of access control policies that you might want to apply differently in your configuration. So a good example of this is that you might want to really lock down from a network perspective all of your dev environments differently than your production environment, which you want widely accessible to the public internet. So I'll just kind of leave on some best practices here. So the big one is let's try to avoid these monolithic configurations. You want to have a kind of one-to-one mapping between a configuration and an environment. You don't want to have a configuration that has huge numbers of environments that coexist within it. This can be inherently non-scalable, and it makes it extremely difficult to manage. And this is something we actually see done all the time, right? Is because it's so difficult to manage these things, we typically define huge numbers of dev environments in a single config, and that means when I introduce a behavior, I have to reconcile that across each instance of that environment, right? Additionally, it makes it very hard for me to maintain versions of my development environments in different configuration states. And lastly, and this is kind of going back to environment topology, is we need to avoid snowflake environments. We need to make sure that not only our CDN environments, but our origin environments are as consistent as possible, right? And this is a huge challenge, especially when it comes to topology, right? We need to also make sure that there's mechanisms in place to allow for differences in topology, differences in potentially even security policies and stuff, but keeps our artifacts common, right? Next, we need to make sure that we're testing CDN as early as we can in the lifecycle. So a bug is always cheaper to be fixed in development than production. It's the same with CDNs, right? So we want to make sure that we're testing these things in development and doing that often, and that we're also including that information in our various commit messages. When we're in production, we want to monitor traffic, offload. We want to understand the effects of these behaviors, and we want to, kind of measure that stuff and use that to inform future releases, right? So it's always good to use various tools like real user monitoring and offload measurements to understand the effects that the changes that we're making have on our performance. And lastly, is another thing we see often is we want to integrate our deployment process for our origin applications with CDN and validation, right? So as we do things like deploy creative releases, right, banner images, stuff like that, we want to make sure that we're using APIs and various tools to surgically invalidate that. We don't want to do kind of broad invalidation for changing just a single object. So I guess I'm a little bit early, but I'll just end off with, check out our developer portal where we have a lot more information on some of these APIs, and we have links to various open source projects we're working on. We also have new capabilities we're working on and various examples of API usage. And you can always tweet us at Akamai Dev to learn more, get feedback. So thank you very much, and hope you guys have a good Devoxx.